So this is your review for your test tomorrow. Your test tomorrow is 6 questions. You have partial fraction decompositions on there, your elimination, and your back substitution. Okay. So if we look at the first set of questions, we're using partial fraction decomposition. We're just setting these up. So if we look at number 1, we are given 2x plus 1 over x cubed minus 6x squared minus 27x. Factor your denominator. Your greatest common factor out of all of these is x, so we're going to factor out an x first. That gives us x times x squared minus 6x minus 27. That 27 has factors of 3 and 9. If the 9 is negative, the 3 is positive. That gives you the negative 6 that you're looking for. So this factors to be x times x plus 3 times x minus 9. We are going to use this and put it into fractions equaling our numerator. So this is going to be a over x plus b over x plus 3 plus c over x minus 9 is equal to 2x plus 1. You are not giving this as your answer. You are getting rid of your fractions. So multiply everything except your answer part by your least common denominator. This is going to give you a times x plus 3 times x minus 9 plus b times x minus 9 plus c times x plus 3 is equal to 2x plus 1.
Does it matter which one you put under A?
No, the order doesn't matter. So it could be a over x plus 3 plus b over x plus c over x minus 9. Doesn't matter. The x could go last under c. Doesn't matter.
Are we going to have to solve it on the test?
On the test, you're going to have both, yes. That's why we're going to do some setting up, some with solving. So for these, when you're just setting up, that's what we're looking for. For number 2, you have 14x plus 3 all over 4x cubed minus 32x squared plus 48x. Your greatest common factor on this one is 4x. So we're going to factor the 4x out first. That's going to leave you with x squared minus 8x plus 12. Your factors of 12 that added to be negative 8 are negative 2 and negative 6. So that gives you 4x times x minus 2 times x minus 6. That means that when you put this all into fractions, you're going to have a over 4x plus b over x minus 2 plus c over x minus 6. And that's going to equal your numerator, which is the 14x plus 3. From here, again, get rid of your fractions. You're going to have a times x minus 2 times x minus 6 plus b times 4x times x minus 6 plus c times 4x times x minus 2 is equal to 14x plus 3. For number 3, I'm going to actually solve this one out. Actually, no, because your next section is solving. So, okay. So we'll do the same thing with this one. Just set up. For 3, you have 12x squared plus 1 over 20x cubed plus 2x squared minus 48. This should be an x. For this one, your greatest common factor from your denominator is going to be 2x. So this is going to give you 2x times 10x squared plus x minus 24. For this, in order to factor it, you're going to multiply your 10 and your negative 24. That gives you negative 240. You want the factors of negative 240 that add up to be positive 1. Your two factors of this are 15 and 16. If your 16 is positive and your 15 is negative, that gives you the 1 that you're looking for. So this is going to get rewritten as 2x times 10x squared minus 15x plus 16x minus 24. So now that you've replaced that middle part, you are going to factor this by grouping. Group the first two, group the last two. The first two you're factoring out a 5x. The last two you are factoring out an 8. So this is going to give you 2x times 5x times 2x minus 3 plus 8 times 2x minus 3. Your two sets of parentheses are identical to one another, so that gives you 2x times 5x plus 8 times 2x minus 3. Now that this denominator is completely factored, put it into a fraction. So you have 3 parts. You're going to have a over 2x plus b over 5x plus 8 plus c over 2x minus 3. And that's equal to your numerator, which is the 12x squared plus 1. Get rid of your fractions here. This simplifies to be a times 5x plus 8 times 2x minus 3 plus b times 2x times 2x minus 3 plus c times 2x times 5x plus 8 is equal to 12x squared plus 1. The next part that you look at, you are using your partial fraction decomposition, but you are solving these. So you're going to do the same thing that we did with the 3 before this. However, you're going to completely solve them out. So when you factor, you're going to set each part equal to 0, solve for your x, then start plugging those in. For number 4, you have 5x plus 11 over 4x squared plus 5x minus 6. Your denominator, you're going to factor that. The 4 times negative 6 gives you negative 24. Your factors of negative 24 that add up to 5 are negative 3 and positive 8. So this is going to give you 4x squared minus 3x plus 8x minus 6. You're going to factor this by grouping. Factor out an x from the first, factor out a 2 from the second. That gives you x plus 2 times 4x minus 3. This is completely factored now. So this is going to give you your a over x plus 2 plus b over 4x minus 3 is equal to the 5x plus 11. From here, get rid of those fractions. That's going to leave you with a times 4x minus 3 plus b times x plus 2 is equal to 5x plus 11. In order for you to find what a and b are, you have to solve for x from your denominator. So that x plus 2 is going to give you an x that's equal to negative 2. The 4x minus 3 gives you an x that's equal to 3/4. If we start with the harder one, which is the 3/4, we're going to plug that in. That's going to give us a times 4 times 3/4 minus 3 plus b times 3/4 plus 2, which is going to have to turn into something over 4, so that's 8 over 4, is equal to 5 times 3/4 plus 11, which is 44 over 4. Your 4 times 3/4 becomes 3. 3 minus 3 is 0, so that cancels out your a. Your b times the 3/4 plus 8/4 gives us 11 over 4b. The 5 times 3/4 gives us 15 over 4 plus 44 over 4. Your 15 plus the 44 gives you 59 over 4. To get rid of that 11 over 4 in front of the b, we're going to multiply each side by the reciprocal. So that gives you that b is equal to 59 over 11. You still need to find a. Use that when x is equal to negative 2, though. When x is equal to 2 or negative 2, you're going to have a times 4 times negative 2 minus 3 plus b times negative 2 plus 2 is equal to 5 times negative 2 plus 11. Your 4 times negative 2 is negative 8 minus 3 gives you negative 11a. The b times negative 2 plus 2 is b times 0, so that cancels. You have 5 times negative 2, which is negative 10, plus 11 gives you 1. We divide each side by the negative 11, and you get that a is negative 1 over 11. If your b is the 59 over 11 and your a is the negative 1 over 11, put those both into that a over x plus 2 plus b over 4x minus 3. This is going to leave you with, where is it? Negative 1 over 11 all over x plus 2 plus 59 over 11 all over 4x minus 3. You cannot leave a fraction within a fraction, so simplify these, and that gives you negative 1 over 11 times x plus 2 plus 59 over 11 times 4x minus 3. All right, so with your back substitution, for number 6, you have x plus 5y minus 3z is equal to 13. Negative 2x plus 3z is equal to 5, and y is equal to 4. For this one, your question's not really going to work out too well. Yeah, this is weird. Well, I don't know why this is like this.
X is 4.
I was going to say, let's change it to where it's x is equal to 4. Normally it's z is equal to something on the bottom. But let's change this to be x is equal to 4. X is equal to 4. So if x is equal to 4, we're going to plug it in to that negative 2x plus 3z is equal to 5 and solve for z. So this is going to give us negative 2 times 4 plus 3 times z is equal to 5. That's negative 8 plus 3z is equal to 5. We move the 8 over, adding it to both sides, and we get that 3z is equal to 13. So we divide each side by the 3 and get that z is 13 over 3. From here, if we have x and z already, we're going to plug those both into the top equation. So that's going to give us x, which we said is 4, plus 5 times y minus 3 times z, which is 13 over 3, is equal to 13. Your negative 3 times 3 cancels out, or sorry, over 3 cancels out, so it's just 4 plus 5y minus 13 is equal to 13. If you want to move the 13 over first, it might be a little bit easier. So that's 4 plus 5y is equal to 26. Then subtract your 4 over. So 5y is equal to 22. Divide each side by the 5. You get y is 22 over 5. Write your answer as an ordered triple. Remember x, comma y, comma z. So that's 4, 22 over 5, 13 over 3. So if we keep 7 with the negative 3y, you'd still, like with this one, solve for y first. So divide each side by the negative 3. And this would give you y is equal to 4. Now, since y is equal to 4, the only other equation that you have for y is the top one. So if you plug that into the top one, you would have negative 3x plus 3 times 4 plus 3z is equal to negative 9. So 3 times 4 is 12. If we move the 12 over, subtract it, that gives you negative 3x plus 3z is equal to negative 21. You're working this with the 2x minus z is equal to 11. You can still solve this. Use your elimination with your two equations and solve for one of those variables. My z's are opposites, so if I multiply the bottom by 3, top stays. Bottom turns into 6x minus 3z is equal to 33. If I combine these, my z's cancel. It's going to leave us with 3x is equal to 12. Divide each side by the 3, and your x is 4. So you have a y, you have an x, solve for z. I'd use the 2x minus 11, or sorry, 2x minus z is equal to 11. So that's going to give you 2 times 4 minus z is equal to 11. 2 times 4 is 8. Move your 8 over. You get negative z is equal to negative 3. Divide each side by the negative 1, and z is positive 3. So if your x is 4, your y is 4, and your z is 3, it's just the ordered pair 4, 4, 3. Yeah, this should be negative because this one's positive. So this is negative also. Thank you. For your next section, we are using elimination in order to do this. If you look here, it's telling you to write in row echelon form, which is like what you just saw for the back substitution, and as an order triple. So we're looking for two things here. So I'm gonna be highlighting two separate things with these. For number 8, you have negative x minus 5y minus 5z is equal to 2. 4x minus 5y plus 4z is equal to 19. And x plus 5y minus z is equal to negative 20. I'm going to start working with the top two equations. So that's that negative x minus 5y minus 5z is equal to 2. And 4x minus 5y plus 4z is equal to 19. To me, it looks like the easiest thing to eliminate here would be my y's. So I would just change the sign on everything here, and then I could add them, and my y's would cancel. So this would leave us with negative 5x minus 9z is equal to negative 17. That's your new number 1. To find your new number 2, use the last equation that you didn't work with yet. So x plus 5y minus z is equal to negative 20. And one of the ones that from the first two. I'm going to use the top one. So that's negative x minus 5y minus 5z is equal to 2. For this one, when you add them, your x's cancel, your y's cancel. You're left with negative 6z is equal to negative 18. There is nothing wrong with this. Just because it doesn't look like your new number 1 doesn't mean you can't work with it. Yeah, you only have one variable within that equation. Use back substitution. If you use back substitution, you can work with, let's use the bottom equation. So x plus 5y minus z is equal to 20. Your new number 1, which is negative 5x minus 9z, is equal to negative 17. And that negative 6z is equal to negative 18. This is that row echelon form. So this is part of what we're looking for tomorrow. Okay? So use your back substitution with this and just start finding for all of your variables. If we use back substitution with what we have highlighted here, we're going to start with the negative 6z is equal to negative 18. Divide each side by the negative 6, and you get that z is 3. From here, use your new number 1. The negative 5x minus 9z is equal to negative 17. Solve for x. If we plug this in there, we're going to have negative 5x minus 9 times 3 is equal to negative 17. The negative 9 times 3 gives us negative 5x minus 27 is equal to negative 17. Add your 27 over. This gives you negative 5x is equal to 10. Divide each side by the negative 5. And you get that x is negative 2. Now that you have an x and a z, solve for y. Use the top equation. You're going to have negative 2 plus 5 times y minus 3 is equal to 20. The negative 2 minus 3 is negative 5. We add that over. That's 5y is equal to 25. Then divide each side by the 5. And you get that y is 5. So remember, with these, you're also giving the order triple. So you're looking for x, comma y, comma z. So that's negative 2, comma 5, comma 3. So two things that are important here, which are both the parts that are highlighted. Hold on. So if this was negative, that means this one is negative. This one is negative. This is negative 15. And then this would be negative 3. Oops. Say that again? Yeah, you just plug it in. Mm-hmm. Mm-hmm. The thing that I'm using to record this isn't really working as fast as I am. There we go. Thank you. You're given negative 5x minus 5y plus z is equal to 17. Negative 5x minus 5y plus 5z is equal to 5. And 2x plus 5y minus 3z is equal to negative 10. When I start this, I'm going to use, look at my y's. My y's all have 5s in front of them. If I look at the ones that are opposites, I can start with these two and then end with these two. So if we start with, let's say, the top and the bottom, I'm going to have negative x minus 5y plus z is equal to 17, and 2x plus 5y minus 3z is equal to negative 10. Again, I'm doing this so that way my y's cancel out. They're opposites. I don't have to multiply by anything. I just need to combine like terms. So if I combine, this is going to give us x minus 2z is equal to negative 7. This is my new number 1. So keep that in mind. Find your new number 2 now using, we use the top and the bottom, the middle and the bottom. Because you didn't use the middle yet, so you have to use the middle. Thank you. It's supposed to just be 7, not negative 7. Okay, so if I use, like I said, the middle and the last, we have negative 5x minus 5y plus 5z is equal to 5, and 2x plus 5y minus 3z is equal, thank you, to negative 10. If we combine, because again, our y's are opposites of one another, our y's cancel. This leaves us with negative 3x plus 2z is equal to negative 5. This is our new number 2. So now that we have two new equations, we're going to use both of those and cancel out one of the variables. Okay, so I'm going to separately write this over somewhere else so that way I'm not getting confused. I have x minus 2z is equal to 7, and negative 3x plus 2z is equal to negative 5. With these, I can just combine them because my z's are opposites. One has a negative 2, one has a positive 2. So if I just combine them, my z's cancel. X minus 3x is negative 2x. 7 minus 5 is 2. Divide over your negative 2. That gives you that x is negative 1. Now, you have two parts of that row echelon that you need. The x is equal to negative 1 is your bottom part. So x is equal to negative 1 is your bottom. Your middle part is going to be one of your new equations. It does not matter which one you pick. There's no right answer for it. No, it doesn't matter. It can be the first new equation. It can be the second new equation. It does not matter. I would use the first one because my x is just 1. Has a 1 in front of it. It's like I said, though, it's up to you. From there, pick one of the original ones. That's going to be your top equation. It's totally up to you, again, which one you use. If I use the bottom one, that's going to give me 2x plus 5y minus 3z is equal to negative 10. So those are my three equations in row echelon. So these three are giving me that row echelon part. From there, plug in. If x is equal to 1 or negative 1, plug that into the x minus 2z is equal to 7 and solve for z. That's going to give you negative 1 minus 2z is equal to 7. We move that negative 1 over, adding it to both sides. So negative 2z is equal to 8. Divide each side by the negative 2. And z is negative 4. Now that you have your x and your z, solve for y. Plug both of those into one of the originals. It does not matter which one. If you want to use the one that you have in the row echelon, you can. That would just be 2 times negative 1 plus 5y minus 3 times negative 4 is equal to negative 10. Your 2 times negative 1 is negative 2. Your negative 3 times negative 4 is positive 12. Negative 2 plus 12 gives you 10, so 5y plus 10 is equal to negative 10. Subtract your 10 over. That's 5y is equal to negative 20. Divide by 5. And y is negative 4.
So when you get x and z, you have to plug the z. You have to plug the x and the z into an original one.
Yep, in one of the originals. It doesn't matter if it's one of the ones that you chose for your row echelon or one of the other ones. It does not matter. So then from here, just put it into an order triple. So that gives you negative 1, negative 4, negative 4.